Okay, so there's the quiz on Monday. 30-pointer, one proof at the end, angle, angle. Okay, I am going to add an extra step to that today, but that's not on there. Okay, one angle, angle proof. And then you guys are going to have to set up a proportion, solve it, maybe factor, maybe quadratic formula. And then make sure you are fully aware of the 3 ways to prove triangles similar and what they mean. Yes, a big part of this is using quadratic formula or factoring after you set up the proportion. I think those are like 5 to 8 points, each one of those. Anything you want to ask? You will get, hold on, you will get more practice on tonight's homework. Over the weekend, the homework is still set up your own ratio, set up your own proportion, use factoring or quadratic formula. That is still on tonight's homework. All right, so please try it out because I am going to check it on Monday. Yes, Sam. 9. Yeah, those ones where you have to use quadratic formula are 5 points apiece. And there's 2 on there. Oh, there you go. 10 out of the 30 points. Anything else? All right, let's get to today's stuff then. Not much. I'm going to extend the angle proofs to 1 step. Got that all set up. We're all ready to go. All right, let's go. This first proof, can you guys just take a look at the proof statement? Because that's a little bit different than something we've ever seen. What is the deal? There you go. How about this one? Okay, so we just switched them, right? Okay, this is the first one. Okay, got it. All right, so the first part, prove those 2 triangles similar, CED and BEF, which we should have good practice in from last night. What's the main way in a statement's reasons anyway? We're going to prove triangle similar. A, angle, yep. This is a parallelogram. Just be aware of the 2 triangles I'm asking for here. Triangle CED, this one right here. Prove it similar to triangle BEF. All right, I'm going to ask you guys now, can you find a pair of angles for me? Let's get angle rolling. Can you find a pair of angles? It's a parallelogram. That's all I gave you. Remember the properties or not? Where are a pair of angles that are congruent? Here we go. 8, start us off. Yep, good talk. It's going to kill me here. 15. Okay, we got the vertical angles right off the bat. Easy to see. DEC, congruent to angle BEF. No big deal. Vertical angles are congruent. All right, how about using the parallelogram now? Does the parallelogram get you another pair of angles? And it should. All right, what do we got? We're going here with the parallelogram. Let's hear it. 8, yep. 12. What do you know about opposite sides of a parallelogram? The and? Opposite sides are congruent and? I'm just asking for the sides. They are, and they're also what? All right. So there should be special types of angles formed by parallel lines here. If DC and AB are parallel, do you see any of the special types of angles? Alternate interior, corresponding, all those we've talked about. Name them. All right, there we go. Everyone see a pair? Now, could have we said the other pair? Angle DCE and angle EBF. Yes, we could, but we'll go with this pair. Can't say they're congruent unless you know what about the lines. They're parallel, so DC parallel to AB. Parallelogram implies opposite sides parallel. Anybody know why I'm not ready to say those angles are congruent? Why, Sam? Go ahead, keep it going. Correct. So how do I get DC and AF to be parallel? Remember it, Hendrik? What do we use? Extensions. Everyone see that? AB is not part of angle F. BF is. So I need to extend AB out and say that DC is parallel not only to AB, but AF. And yep, just what Hendrik just said. Extensions of parallel lines are parallel. And now you can say those alternate interior angles are congruent. Angle CDE congruent to angle EFB. Somebody give me a good reason why now. What reason have we been putting in here? 11? What reason have we been putting? Yep. Do I have two pairs of angles? Okay, triangles are similar. Just make sure you write that similar sign, not the congruent symbol. Okay, now we're going to add in one extra step. Now that I know the triangles are similar, what do you know about the sides? Don't tell me they're similar. What do you know about the sides now, Remy? They're in the same ratio, same proportion. And that's what they're asking me to prove in B now. CE, DE, BE over FE. Those are corresponding sides in those similar triangles. So here's our extra step today is to say the sides are in the same ratio. And instead of saying corresponding sides and similar triangles are proportional, we do have a shortcut version. Remember CPCTC? After we prove triangles congruent, we said CPCTC. Same thing. After we prove the triangles similar, we can say CSSTP. And what's that stand for? Corresponding sides and similar triangles are proportional. If you want to use it, same deal as CPCTC. Got to be in the right order. You start going C, T, S, P, X, Y, Z, not going to fly. Got to be in the same order. Questions? All right, let's go to that second one because this one doesn't make you great. Take a look at the proof statement for me. I don't know if you're freaked out by that or not, but remember I showed you the colons, it's just ratio. So if you guys don't like this, hey, take a look. If you don't like this, you can rewrite them as fractions if you want, because all those are ratios. FC to DB is equal to AC to PB. So if you don't like the colons, go ahead and write it as a fraction instead. Same thing. Five, here we go, Fiona. This is not true until I know what about the triangles. They're similar. So I'm not even touching this yet. I need to find triangles that are similar. Now, hey, guys, look at the diagram. How many triangles are there? A lot. A lot. And we need to find which two do we need to prove similar. What's going to help us up here to find which of those triangles in the diagram are we need to prove similar? Look at the proof statement. What's one side length in the proof statement? Give me a side length in the proof statement. Or one segment. Just give me one segment in the proof statement. FC. Everyone ready? Here's FC. I think that's a full side in one and only one triangle. Everyone agree? And that's triangle AFC. So we found one of them. Give me another segment in the proof statement. PB, DB, doesn't matter. Ready? I'll take PB. I think that's a full side in one and only one triangle. Everyone agree? So do we see the two triangles you need to prove similar for me? AFC and PDB. All right, how we doing it? Let's see. Oh, it's isosceles. Great, that might help us. AB is congruent to AC. And I have an altitude and perpendicular lines going. So I will open it up to you guys. Can you find a pair of angles there? Either being the triangle being isosceles or the altitude and perpendicular lines. Do you see any angles you could possibly use? 25 in the house? Any angles? BDP is a right angle, yep. Which means there's got to be another right angle in the other triangle. Where's that right angle located, Mason? Oh, don't say I don't want to hear the because. You're correct. Okay. I am not going to put these in the same step. Why? That they're right angles. Fiona? Different reasons. Different reasons. So let's start with Mason's first right angle, which is PDB. Angle PDB is a right angle. Why? PDB. Why is that one a right angle? What in the givens told you? Let's go. Let's hear from 28. 28. All right. How about a 7? Yep. How about a 29? Yes, in this case. And then let me go to Mason's second right angle, which is AFC. Little bit different reason now. It's not because of perpendicular lines. It's because, oh, yeah, 16. Yeah, definition of an altitude. Altitude forms right angles. I'll take any of them. Like it. I like it. Still got to say, what? Even though I did it in 2 steps, still have to tell me that the two are congruent. Nice job. Okay, I need another pair, though. Nobody's mentioned isosceles triangle yet. Can I get another pair knowing that triangle's isosceles? 24, got another one for me? They are. That's incorrect. So there's my second pair. We'll talk Y in a second. Angle B congruent to angle ACF. Nice job, guys. Nice job. Nam gave us those. Why are they congruent? How do you know that? 27? Nope. How about it? Whoa, okay. Calm down. Thank you. In a triangle, congruent angles across from congruent sides. All right, nice job. That whole group there, nice job. Now I know what about the triangles. They're similar. Need a nice statement from somebody now. Match up the angles and sides. 10, going to match them up for me? Yeah. How about 29? I needed the statement, though. Triangle ACF. Hold on. ACF, got it. Similar. Oh, yo, almost had him. I was waiting for it to come out of his mouth. How do you do? ACF. I don't know about PDB. Yep, and now the triangles are similar. Sides are in the ratio. CSSTP. Whew. All right, we're good. Monday on the quiz, though, you only have to go up to angle, remember. I'm not going to ask for CSSTP. All right, we're going to end this with one pretty hardcore algebra problem to get you ready for Monday's quiz. Do you have this one on your paper, or we good? Okay, I got one thing correct. Yep. All right, AB is parallel to CD. I need to know that because now the triangles are similar, and you guys can set up a proportion. All right, let's find out who's going to help me set up this proportion. 1. Here we go, Maddie. Ready? You got two sides that correspond for me. Okay, everyone, just stop right there. Everyone, 4 and x plus 3 definitely correspond. All right, you got your work cut out next. Okay, hold on. Don't say anything yet. I just want to go slow so everyone knows where we're going. Does everyone look at the side x minus 1 corresponds with? You should not be putting a 2 here. 2 is not a full side. Matt should be giving me the length of FC right now. Go ahead, Matt. Length of FC. Thank you. X plus 1. He combined the -1 and the 2. Guys, are we okay there? I'm nervous about Monday here. We okay on where to get that right there? X plus 1. All right. Somebody's going to be up cross multiplying for me. 16. Hi, Thomas. Yep. And then take your time on this next one. Double distribute.
X squared.
Yep.
Plus 2x.
Yep. Nice job. There you go. What's the highest exponent, everyone? 2. Got a factor. All right. So let's move the 4x and the 4 over for me. Here we go. 15. Want to move those over for me? X squared. How you moving the 4x over? Yep. And what do you end up getting? Minus. Yep. And how you moving the 4 over? So you're going to get minus. Yep. All right. Here we go. Some of you are looking a little confused right now because you're trying to figure out two numbers that multiply to what? -7, but add 2. -2. Let me know when you get there. Anybody? Because there are no numbers, right? There are no numbers that multiply to -7 and -2. So where are we going to have to go to right now if we can't factor it? Quadratic formula, yep. And hold on, time out, stop. Even before we started this problem, look at the directions, please. What up there told me, hey guys, you probably won't have to factor. Thank you, simplest radical form. So if you see that on Monday, guys, don't waste your time trying to factor. It's not going to happen. All right, simplest radical form only happens from the quadratic formula. Let's do it. X equals, I'll give you this on Monday, remember, -b plus or minus b squared minus 4ac all over 2a. All right, need some help now from somebody. 14, what's the b value up here? So when I plug it in, Caleb, to the formula, it's going to become what? +2 plus or minus. Guys, do not try to be a hero. Store the darn numbers in your calculator and figure out b squared minus 4ac. All right, let's go. A is 1, B is -2, C is -7. Midterm. I am not going to bring any extra calculators with me. If you need to borrow one, that is fine, but you have to come to a review session, though, to borrow a calculator. What is the number you are getting underneath the radical? Here we go. 20, we have a 26? Yeah, we do, Jack. Oh, no, don't even try to be a superstar and simplify it. I just want the number underneath. What? No, you weren't. You got it simplified. I just want the number, the b squared minus 4ac. What did it come out to be in your calculator? That's all I needed. Stop. All right, don't try to be a hero. I'm trying to show off. What's the number on the bottom? 2 times, what's my A value? So 2. All right, yep. Jack was correct. You can simplify 32. And you're going to have to simplify on Monday. Anybody find the biggest perfect square that goes into 32? 19? 4 does go in, but there's something bigger. But I need the biggest if we're going to simplify this correctly. Something bigger than 4. 16 times 2. All right, everybody. So 2 plus or minus, what's the square root of 16? 4 radical 2 over 2. Are we done simplifying? No. No. The 2 in the bottom, in the denominator, goes to the left and to the right. So ready? 2 over 2. Plus or minus, whoo, it belongs to the right side. What's that reduced down to? 2 radical. 2 radical, that can't cross them out. So just 2 radical. Guys, take a look at this right now. We okay getting to this point? We have 5 minutes left in the class, and this could get real awkward as us just staring at each other until I hear from somebody why we're not done. Think you know?
Yeah, because it can't be plus or minus because you can't have negative sign.
Everyone go to your calculators right now for me, please. Please do 1 minus 2 radical 2. 1 minus, everyone knows where your radical button is? 1 minus 2 radical 2. I don't care what the number is, but what type of number is it? Isn't it negative? And I don't think right here, this side up here, I can't plug it in because I'll have a negative side. So even with quadratic formula and diagrams, you are going to have to probably reject one of your answers. So what is my only answer up here? 1 plus 2 radical 2. Because the minus version leads to a negative side length. Real quickly, because you're going to have to do this on your homework. What if I said round your answer to the nearest 10th? What would you go in your calculator and do now? If I said round your answer to the nearest 10th, because you're going to have to do this on the homework. Go to your calculator. 1 plus 2 radical 2. And what would that round to the nearest 10th? 3.8. So if I said round to the nearest 10th, you just write x equals 3.8 and no radical anymore. Flip it over, start it. Here we go, right to the bell.